Hi, my name is Mr. Reynolds, Jack Reynolds, and I'm going to do a mock lecture on Pythagorean Theorem. I'll talk a little bit about what I've written up here because I know we're going to keep that kind of zoomed out so that you can see everything, but the writing may be a little too small for you to make out, so I'll go through it. Typically what I want to do is I want to have the agenda written on the board. I want to talk about what we're going to be doing for the day. I have the day's lesson written on here, Pythagorean Theorem. The agenda, first thing is going to be a bell ringer. Always like to have a bell ringer, something to focus the class right off the bat. I would expect that would take about 10 minutes of class. The second thing obviously is going to be the lecture on the day's lesson, Pythagorean Theorem. I'll introduce it. We'll do a little bit of a review of triangles and talk about a right triangle. Then we'll work through some examples. And that would constitute the lecture. Probably I want to keep that under 20 minutes simply because the attention span of our students these days, they say you get about 1 minute for each year. So beyond 15 or 20 minutes, I'm going to start losing students and I want to keep them focused. The third thing is group board work. Because you can see I've only got a limited board space here, and that's not always going to be the case in every class. We'll talk about this some more, but after I'm done with the lecture, I'd have the students broken into groups. One person from each group at a time comes up, and the group kind of coaches him through working a problem on the board. If we have enough board space, then everybody can come up at once. If we don't have enough board space for everybody, but maybe we have enough for one person from each group to come up at a time, so that we're not having to do, I think we'd have room for maybe 3 groups in this case. Last thing, I'll pass out the assignment. Last 5, 10, certainly no more than probably 15 minutes of class would be left for the assignment that I'll pass out. Whatever's not finished in class, and most of it won't be because we won't have that much time, will be done for homework. But I want them to see it and have time to ask any questions they might have about it. This is also a good time where if I have some students who are kind of advanced mathematically, they're real comfortable with the material, I might have them help me work with some of the students who are struggling. That way I keep those advanced students focused on the class, keep them engaged here, and at the same time we might be able to speed up the pace because we're having some assistance from good students working with some of those who are struggling with the material. I think that might be a way that we can keep everybody focused on the class, keep them engaged, and keep the pace moving. So anyway, so as I said, the first 10 minutes is the bell ringer. I've written it here. I've got 3 different triangles, and asked them to identify the equilateral triangle, the isosceles triangle, the scalene triangle, the acute triangle, obtuse triangle, and of course the right triangle. I've added a little bonus. What is the, to write the formula for area of a triangle. This also functions well as the day's review. So after about 10 minutes, after everybody's come in, first 10 minutes of class, it's nice and quiet, they're working on their bell ringer. Hopefully we'll then get up and talk about the day. I'll start reviewing it. I'll collect the bell ringer, of course, probably good for maybe a quiz grade or a homework grade. We'll work that out with the students. Maybe fill in for a quiz that they scored low on, something like that. So we would go ahead and move through the review at this point. I'd talk about Pythagorean Theorem, and we would want to maybe, in this case, the previous day's lecture, presumably what the bell ringer's over, a quick review of the day before, happens to, and this is usually the case in math, lead well into the next theory, to the next lecture on Pythagorean Theorem. So we have these triangles up here, and we're going to want to talk about those a little bit. Equilateral triangle, of course, is a triangle where all 3 sides and angles are the same, and those are denoted accordingly. And that would be a part of the introductory lecture that I would have done the day before, or maybe 2 days before, where they recognize these symbols and what they mean and denote mathematically. The next one, isosceles. The isosceles is when you have 2 interior angles and sides are the same. That would obviously be that one. And a scalene, of course, is when you don't have any of the angles or the sides the same. These are kind of broad categories. The acute triangle is when you have a triangle where none of the angles, interior angles, are greater than 90 degrees, obviously. And that would be B in this case. Obtuse is where you have 1 greater than 90 degrees, and that would be this angle, so it would be the triangle A. And then you've got the right triangle, and again, that's denoted with this little square in the angle where the 90 degrees is. Formula for the area of a triangle is half times base times height. We would have, of course, had already had some homework assignments over that, so I would certainly expect them and hope that they would have that down pretty well. That's an easy formula to remember. So we'd spend a good 10 minutes maybe doing some of that review. We might also want to talk about some of the algebra that's going to be required to solve some of the problems related to Pythagorean theorem before I start talking about what it is. And while we're still in this review phase, we might talk about that. One of the things you might want the students to review is, of course, going to be the how to resolve square roots. Hopefully, they've got this down up to 12, or I should say up to the square root of 144. I would expect them to know based on the times table. And if that was something they were struggling with, then I might recommend some after-school, before-school tutoring to really have that down. I think that's a reasonable expectations of kids entering freshman high school math, which I think is where you would typically find geometry, freshman, sophomore level. And I think a good familiarity with the times table is a reasonable expectation. So hopefully they won't find any of these particularly difficult. So I wouldn't want to see calculators out, obviously, to resolve square root of 144 or square root of 64 or anything like that. Hopefully, based on the times table, which typically runs through 12, they'd have that down pretty good. Anything more than that, square root of 169, you know, some of these you might be less familiar with. You can go ahead and use your calculator for that. So we definitely want to talk about the square root and expectations of how to resolve that. The other thing, some basic, some real simple algebra equations. Be sure that they're familiar with how to solve those. I know some students continue to struggle with that. We'd want to review that, of course, so that we would be able to solve for x, because you're going to have to be able to solve for one of the sides of a right triangle. Be sure they have that. And the other one, and this can be a little tricky, of course, is going to be when you're talking about if you have a variable that's second degree that's been squared, and you have to solve for x there, because the thing that has to be, you know, when you're solving for a variable, you do the opposite of what's being done to it in reverse order of operations. In this case, the variable is being squared, so the opposite of squared is to take the square root. By taking the square root of anything squared, you're obviously going to be left with itself. The tricky part is, of course, you know, realizing that whenever you square, whenever you're looking at a variable squared, or any even degree there, any even root, it's going to be, you're going to have the potential for multiple solutions. In this case, it's going to be either plus 12 or negative 12, positive 12 or negative 12, because obviously negative 12 squared is also 144, as is the positive 12. Now, because we're going to be dealing with triangles, obviously you don't have a negative side length, so that's something, but I would still encourage the students to get into the habit of writing it this way, because it's going to come in real handy later in algebra, and by and simply denoting, in this case, when we're dealing with right triangles and only positive numbers, circle that positive, indicate that you understand that that's the case. So that would be kind of the quick algebra and geometry review that you might want to do. These are the things that want to know for the for solving Pythagorean theorem as it relates to right triangles. So then the lecture and introducing the actual material for the Pythagorean theorem. Pythagorean theorem relates to the relationship between the three sides of the right triangle. So if I have a right triangle like that, what Pythagorean theorem says is that the square of the hypotenuse, and the hypotenuse is always the side opposite the right angle, so the hypotenuse squared, or in this case c squared, is the sum of the other two sides individually squared. That is the essence of Pythagorean theorem right there. C squared equals a squared plus b squared. The square of the hypotenuse is equal to the sum of the other two sides individually squared.